right. Hello, everyone. This is our second Spark session. We're going to focus on machine learning libraries this time, and that should help you with assignment 2, right? So here is the agenda, new skills, and some key reminders for assignment 2. We're going to look a little bit at the markdown of the Jupyter notebooks. We're going to look at the parser function. This is a very important part of the code, all right? We're going to look at how you use the pipeline to run logistic regression. I'm going to give you a lot of part 2 tips. And there's going to be an additional example that's not in the classroom, but you're going to get it today. There are going to be some additional visualizations that are not in the classroom example, that not necessarily something that you're asked to do, but that's something that I want you to walk away with, let's say, okay? There's some bonus histogram and correlation plot code that you're gonna get today, all right? It's not something that you're explicitly asked to use in part 2 of the assignment, but it's something that will help you. It's something that's good to learn, let's say this way, right? So now, what new skills are you learning? You're learning how to integrate new skills, right, into role of data scientist. You're learning data management, right, data engineering, but most importantly, unlike from your previous coursework, you are working in the cloud, right? You're learning the benefits of working in the cloud. What happens when the work is saved on your local PC and the hard drive blows? You lose your work, right? Here, you're not saving the work on your local PC, you are saving the work where? To the cloud environment, right? But there's a little price you need to pay, is that the limit on resources. So you have to watch out the environment that you are running, and you need to make sure that you are not running the environment at the time when you're not running the code, right? You don't want to run your environment on your account while you're sleeping, just an example, right? So there are benefits and there are things to watch for, right? You need to manage your resources. That's what you've been learning in the last assignment. So hopefully none of you have used up more than 3 hours for the last assignment. 3 capacity hours, hopefully you understand what I'm talking about, right? You get 10 capacity hours per month, right? Those are not the clock hours, but those are, it depends on how much resources the environment consumes. The environment that you're using is consuming 1.5 capacity hours, right? Capacity units per clock hour. So that gives you 6.6 hours of time per month that you can run the environment, right? So you need to watch out. Remember, we talked about the stopping environment when you're not running the code, right? So please, I don't know how many times to repeat this. Do not enter the credit card number. You're not going to get more capacity hours. You're not going to get the free hours, but you're going to get yourself more, what? More trouble. Okay, so please don't do that. This cannot be undone. You're going to lose your account. Then you cannot get another code this calendar year, right? You get only one IBM Cloud code per calendar year. So then this is it. Your account is not going to be academic anymore. You not only be charged, but there could be some features on that account that are not in the academic account. I'm not quite sure how things are working on a paid account, and I might not be as good of a helper to you anymore once you do it, right? So please, last semester still somebody did it, so please don't do it. Don't be that person, okay? Please. So do not upgrade your account. Please make sure to stop the runtime environment. Not sure how many times I repeated, but some people still forget. You need to stop the kernel before you exit the notebook, and I'll show you how to do that last time, right? And please do not contact IBM I did have a student who attempted to ask IBM to fix the error in the code, something like that. I know it sounds funny, but it's not, trust me. So do not open tickets with IBM, you open the Salesforce ticket, right? So you want to upload the data to the project before you upload the notebook. It's important, right? Do not delete the object storage. And please do not open the two notebooks in the edit mode at the same time, because you're going to be consuming the capacity hours twice, right? You're running two instances of the environment, consuming twice more hours. When you run the notebook, please do not skip the cells. You want to run all notebook cells from top down, right? Because what happens when you start the new sessions, when you start new kernel session, everything that you defined in the past session no longer in memory, right? So you have to start, when you run the notebook again, you have to start from the top cell and run all the cells, right? And all cells must be executed in order. You cannot just skip the first 10 cells and go and execute cell 11. No, that's not how that works, all right? You have to rerun the whole notebook. All right, makes sense? Hopefully it does. This is the correct environment still. Spark 3.4, Python 3.10. But be aware that Spark 3.5 is already out there. It's not in the cloud yet, but it's out there. So it means, what does it mean? Anytime, we don't know when, there is no specific date, but the environments that are currently in the environment that we currently have on IBM Cloud, right? At any time they could put 3.5 in there. If they do for a while, maybe for 3 weeks, they will have both at the same time, but then 3.4 will be gone, right? Usually it works like this. There is no specific timing, right? But you don't want this transition to happen while you're working on assignment 2. So if you finish assignment 2 on time, you'll be fine. But if you wait until the end of semester for some reason, I'm not sure why, but it does happen, then there is a risk of 3.5 being in there and 3.4 not. So if that happens, well, there is no guarantee that the code will still work. I don't know, maybe it will, maybe it will not. Once in a while, an update requires making some changes to the code. So I'm just telling you, please get this done on time. That's the bottom line. Get the work done on time, okay? Do not wait for the environment to be deprecated. So try your best. I know things happen, but I'm just telling you the technical impact, all right? The risk of environment being deprecated. All right, okay. And now we're gonna look a little bit about the markdown cell syntax. So what you have for this assignment is that you've got the 3 parts, right? The first part is a Titanic notebook that you got. In there, that running that notebook should not take more than 1 hour, more than one capacity hour, because what you're asked to do in there is just a couple things. The credentials block, right? You asked to do the credentials block and just the bucket name. But I'm gonna quickly look at that notebook right now to show you this markdown cell syntax. So if you see this, you've got the level 1 heading, right? You have the level 2 heading. So here, so this is a project, right? I uploaded the notebook. I uploaded the Titanic notebook. See this? So now I need to go to assets, right? And unfortunately, I'll have to open it in the edit mode in order to see the code, right? Well, not to see the Python code, but in order to see the HTML, right, the markdown cell markup. Because see, when I just click on the notebook, it's gonna open it in a view mode, right? So when I open it in a view mode, I need to see what you need to do in here. I need to show you. So take a look at this. You have to do this, right? You will have to do this credentials block. Follow the steps you did in your other assignment. Then you will scroll down to where it says bucket and copy the bucket name, right? That's all. And you're gonna run it. You're not asked to do much in this. Okay? Then very important is that you'll need to save the output as an HTML. Do it as soon as possible and do it before you run out of hours. Trust me, things happen when the students work on a part 2 of this assignment. But let's go back and let's put in the edit mode because I have to show you, I need to show you the syntax. Well, see this cell? This is not the code cell. This is a markdown cell. Markdown cells are very helpful with documenting what your notebook is about. And this is a level 1 heading. How do we put level? Well, look, I double click on this line here just to see the code. So what it is here, it's one hash sign, one hash mark, right, followed by the actual text. So this is going to be level 1 heading. So when I run this, it's going to look like a level 1 heading. That's what it is, right? So again, how did I get to see that? I selected it and I double clicked on the blue line. So that shows me the markdown code for this, right? What is this? This is just a text, nothing in here, just a plain text, right? What is in this cell? What's going on? This is the level 2 heading, right? This is double hash mark. So here, this one is, it's a bulleted list, right? But take a look, the bullet is the circular dot, right? So how do you do this? You have to put this little hyphen, will make it a circular dot bullet. Now over here, each item here is a link. Each menu item is a link, right? So here I have a link on the Titanic data, right? Titanic data is a link, but where does the link point to? It points to this anchor. See, there is somewhere in the document, there is an anchor called Titanic data. So if I go here, see this? I have to have an element in a document with an ID called Titanic data. See this? So this link in here, so first of all, it's a menu, right? It's a bulleted list. How did I make it bulleted list? I put a little hyphen. That's gonna make it like it's gonna make it a circular bullet. Then what I did, each item in the menu is a link, right? So here, this is a link. The link text says item, it says Titanic data. This is what the link text says. This is where the link takes. That's a location, anchor in a document where the link takes. Then here, I have this. See this? I specified this. Titanic data. See this? I have this element ID. So whenever this link is clicked, it takes me here. See? And I did something like that for all of them. I did something like that for the whole menu. Like, for example, see this load libraries. When I click on the libraries, it takes me here. Why does it take me here? Because if I look at the code, see this, I had this load libraries ID in here. So you may copy this structure, right, from table of contents. Well, what is this? This is the link, right? But this is an external link, see? So like if I run this cell, see how that looks like this? That link, oops, I should run this one. That link takes me to the outside web page, right? So what is the syntax for the outside link? So here, see this? In square brackets, I see the link text, and here I put the link location. Where does that link actually takes me to? Right? So that's that. What else do I see here? Well, you don't need to know HTML, but it does not hurt to know just a little bit. What is this? Here we have an HTML code for the table. So I'm going to select this cell and take a look at this. So this is the opening tag, right? So see this table? that means that this is the start of our table. Then there is a closing tag for the table. What is a table? The table consists of what? Rows, right? Each table consists of rows. So how do we do the rows? We start tr tag is the start of the table row, right? Then tr tag like this tag, right? It means that the row ends. Is this? So the slash tr, it means that the row ends, new row starts, right? Then we'll scroll down, new row ends, right? Table row. Each row consists of what? Cells, or cell is also known as table data. This is table data starts, table data ends, right? So C cell starts, cells ends. The first cell is just an empty, right? So because see, if I run this, take a look at this. Each of this is a cell, right? So here I just name, I just put in the first column here, I put the column position number in the data. And because Python starts numbering from 0, I just started from 0. So see that? And I left this column header blank. But still, I have to create the cell, right? How many cells are in the first row? 1, 2, 3, at least 4, right? So let's look at that. This is the first cell, right? So for a cell, this is the second cell. It says variables, and this B stands for bold. I want to see this bold, right? This is just the HTML tag for the bold. Then in another one, I just say description. This cell, I wanted to add a picture, but I want this image to span across 7 rows. So the remaining rows will have 1 cell less. Why? Because the last cell in the first row is going to span 7 rows. That's what it's doing here. And what is this? This is, you don't put the image, you put the link to image URL. So this is just the URL of the picture on the web, right? That's how you do it. This is just the HTML code to put the image. And then here you specify the source, and that's that's a location where the image is, right? So if you take this and paste it into the web, then see what happens, right? You need to specify, you don't copy and paste the image from your PC. You need to specify the image location on the web. Oops, not sure what's going on, but I tried to paste this URL. Well, not sure why. Not sure why it's not doing it now, but what I'm trying to say, this is the actual. So if let's run this. Let's run it to see that this is the image. This is the image URL. And if you want to, you can actually do this. You can do this. You can check copy image link. And if you copy image link, then you can paste it in another browser. I hope that does it. I hope that works. Here we go. Sorry, I could not get it to work before, but that's where it is. See that this is the image. This is the actual image source. See? So you take this URL of an image, right? And you put it in the code of the cell, right? So see that just the you just need to specify the image location on the web. That's what you do. Oh, it's because I see what the problem was. When I copied this URL, I forgot to grab the letter H. That's why I was getting the issue. But anyway, see this, and this is just basically the column reads. You can play with this, okay? So that was the some explanation of the that was some explanation of the HTML, right? And the markdown cells, okay? That's what it was. So now what I need to do, I need to stop the kernel. If I'm no longer running, I have to conserve the hours. So what do? I do here, I go shut down, right? Now what else do I do? I'm gonna leave the notebook, leave, right? I also need to make sure that actually nothing is running. I may sound paranoid, but I want to make sure that I have all my hours saved, right? So I go and I check, nothing is running now, we're good. But this is what I have used so far this month, all right? So now I hope we're good so far. Now let's take a look. What else do we have in here? Oops. So I talked about this. I explained the HTML syntax, right? Whether you want to use a picture in a part 2 of the assignment, it's going to be your choice, but just know that it's possible to do that. So next thing is parsing data. So we will need to look at the I can look at the Titanic notebook now, but I'm gonna look at it in a view mode, okay? To save the hours. So now I go to the here. That's a project where I saved it, and I intentionally did not run it because I I don't want to do your assignment, right? So I'm just gonna click here and click view to open this notebook as a view only, right? So basically what you're doing in here, this is the important part here. Uh, you're reading data from the data file, from the CSV file, right? So what you have to do is you need to parse the data that you are reading into for the regression, right? So what you do, you define something called the label document. The label document can consist of three parts. First part is a unique identifier. It's something that uniquely identifies the record. Like in this case, you are reading the Titanic data. What uniquely identifies the Titanic record? There is a person ID, something like that, right? The third part is a label. This is something that you want to predict. So in the Titanic data, you're predicting whether the passenger survived or died. So that's a label, right? And person info is a delimited list of columns in the data that you want to use as predictors, okay? Label must be either 1.0 or 0.0. So 1.0 means the passenger survived. 0.0 means that the passenger died. So we need to define the custom parser function that will create this label document, that returns this label document. We have a unique identifier, right? We have a set of delimited set of fields that we use to predict whatever we call label, right? You want to call it label. Do not delete this word. Do not delete the word label. Do not rename it. See, we're creating the label document. That's what it's called. All right. So basically, it will take one line, right? And it will return the label document. And very important, when you call the parser function, right? You want to make sure that you exclude the column header. So I'll show you what's going on. So let's look at the parser function first. Where is it? Here. This is a very important piece of code in this implementation, right? So what it's doing is taking, first of all, this will save you hours on this assignment. What it does here, see this list of columns in the data? The first column, right, it's at position 0 because the numbering in Python starts with 0. The first and last name. Then pick class, age, sex, wife, and person ID. Let's see how this fits into the label document. Person ID uniquely identifies the person, not the name. Why? Because there could be more than one passenger with the same name, right? In fact, name is a PII, so that's personal identifying information. This should not be used as part of the analysis, right? Remember that piece, okay? It's hard to hear me? Oh, well, how about now? I'm trying now. Can you hear me now? Not sure why it's hard to hear me. Okay, now, what I'm trying to say here, name is a passenger first and last name, all right? That column, it just uniquely identifies the person, but it's not useful for analysis, but it's at position 0. P class, that's a passenger class. First, second, or third, right? This is the economical status. So we have the passenger's age, sex, whether the person survived. The values in the actual data are 1 and 0. But this is a label, right? We are predicting if passenger survived, and label is located at position 4, right? So this is here, it's at position 4. So what we need to do is we need to make it 1.0, right? That's what it's doing. If value is greater than 0, which is a 1, right? Then set it 1.0, otherwise it's 0.0. That's what it's doing with this label piece here, right? Then this here is a concatenation of columns that I want to use to predict if my passenger survived or died. Okay? Which columns am I going to use to predict? Not going to use name, right? Of course, I'm going to use the passenger class. I'm going to use age, sex, and that's it, right? Because person ID is, it uniquely identifies the person, right? See this? I pass it in a label document. This is the identifier. Here, I'm taking the delimited list of columns that I'm using as predictors. And this is a label that I have to code as 1.0 or 0.0. So see here, where is this function called? So if I scroll down and scroll down more, right? I need to find it. It's called in here. What it's doing here is this. We need to exclude the first row, right? We don't want to parse the first row. How do we know? The one of the columns called name, right? So if you were going to look at the first row in a file, one of the cells contains a text name. So if one of the cells in the row contains the text name, we exclude that row from parsing. Remember, lambda in Python, it's like a function, right? So see here, what it's just doing is that it filters out, it skips if the row contains something like name, right? And then it will take everything else and send through the parser, right? Then it's gonna show, it's gonna print, it creates the RDD, right? It creates a data frame, browser. See this? It's a data frame, it creates a data frame of the labeled documents. Then we print the first 5 records. Over here, you want to pay attention because if the first line in the output shows the column names, then you did not exclude the column names. See that sometimes the students miss this piece when they do when they edit the code for part 2. They miss it, and the result is inaccurate because the data that you're going to use for part 2 does not have a column called name, right? So you have to edit this. But then what else does it do? It's gonna we split the data into the test set, right, and training set. I know that in the earlier coursework, you were told to use 70 and 30%, but you can play around with that. So we have a test data, we have a train data and test data, right? We use the train data to build the model and then the test data to evaluate the accuracy, right? But here it also checks the accuracy of predictions for the training data. So that's what it's doing here. It's using the pipeline to build the logistic regression model. Then it's gonna do predict for the test data and training data. And another thing to watch out for is that when you print the area under the RAC curve, that area should be always between a half and a 1. If your results show area under the RAC curve plot under 0.5, it means something is wrong. So watch out for that, right? So here, I'm only looking at Titanic data right now. I'm gonna look at I'll show you another example shortly. But this is what I was just talking about. I was talking about the Titanic example. I'm gonna talk about another example, just as a bonus, right? But before I forgot, it's important when you read the data, this piece of instruction, do not miss it. You need to enforce schema true. Otherwise, later on, when you start running analysis, when you're doing explorations on your data, right? When you're looking at somebody's age, you're not interested to know the average ASCII value of the age. You want to look at the age. You want to make sure that you're reading the numbers as numbers, that you're not reading numbers as characters. So that's why this line in here is very important when you read the data, okay? Just remember this. And trust me, most of the code errors happen in the parser function for this assignment. Some students cannot get the part 2 to work because they don't edit the parser function. They attempt to plug in data to parser function it is. Then they're not predicting if the baby was born under the weight, right? They are predicting if mother is a smoker. Totally different analysis. Everything is incorrect, right? So you want to make sure that you edit the code, right? So now this is an example I promised, and I'm gonna give you a copy of data and I'm gonna give you that notebook just for you, something to walk away with, because we want to make sure that this session adds value to what's already in the classroom, right? Plus, you have some of the theoretical questions in the assignment, so it may help to discuss doing the correlation plots, etc., right? But here, in this case, in this data, we are predicting if somebody is at risk for the 10 years of coronary disease. So we have the patient information, right, including gender, age, education, etc. And there are also some, if the person has is on blood pressure medicine, there are some uh, vitals here, these such as blood pressure and the cholesterol, the body mass index, etc. But the goal is to predict if the person is at 10-year risk of coronary disease. In this data set, there are 17 columns, right? And the labeling starts from position 0. So I'm gonna now show you, and I already ran the code. So we're gonna just open it in a view mode, and I'm gonna give you the notebook with output, okay? So let's go to this full demo. Okay, let's see. This is this one, and I'm gonna go to the view. So let's look at the view. And again, just the headings, table of contents, right? So I've got this here, and I've got a different picture here, right? See that? And then I listed all my columns and their descriptions in here. Well, this cell here is just loading the libraries. What is this? Well, I listed all my columns here again. Why? Because I want to make it I want to help myself here as I'm writing my parser function. But in here, I played around because there are a lot of columns, and I tried to run this model as different combinations of columns with some columns excluded. I tried that, but I commented it out. I left it commented out. But here, the idea is first of all, again, remember I have to create my label document where I have a unique identifier. I have a delimited list of columns that I want to use to predict the column of interest. And what's a column of interest? I want to know if the person is at risk, right? So here, that's a label. Again, I'm checking if it's greater than 1, then I want if it's greater than 0, then it's 1.0, right? It's a 1. Otherwise, it's 0.0. Label has to be 1.0 or 0.0. So that's a column I'm predicting in the position 16, right? I did not take Titanic code to plug in because otherwise, if I took the Titanic code, I would have been predicting if the patient is a smoker. I don't care if the patient is a smoker. I need to know if the person is at risk, right? Smoker is one of the predictors here. And what is the ID? It's in position 0, right? Then I took the remaining columns, just for the first run. I took the remaining columns as predictors, right? Well, of course, you're gonna see that some columns here could depend on each other. Like, for example, you have a column, notes here, if the person is a smoker, and at the same time you have a column that tracks how many cigarettes per day. Of course, it's obvious that if you're smoking more than 1 cigarette per day, you are a smoker, right? So in theory, you probably want to exclude one or the other. You probably don't want to have, what's it called? It's called collinearity, right? Remember from past courses where the predictors are not independent from each other. So in this case, if the person is a smoker, a number of cigarettes per day. Of course, you are a smoker if you smoke 10 cigarettes per day. So you would probably want to keep one or the other, right? But just as an example, first I included all of them, right? Here is just accessing, this is just reading data, that piece, right? If you wanted to run it on your account, you would have a different, well, the credentials will be totally different. You would have to rerun the credential block. It would be your credential. It would be your bucket name, right? So keep that in mind. If you were going to actually run it, you would have to redo the credentials piece because those would have been your credentials, not my credentials. What you see here is my credentials because I ran it on my account. So I read the data, that's a data preview, right? Well, this is just print schema. It's gonna show the columns and their data type, right? And if they can have nullable, true means the column may have missing values, right? Remember missing values from a prior coursework, right? Null values. You're gonna see that again this semester too. But see here, this is just showing the data type. And if for some unknown reason you see age as character, it means that at the time when you read the data, you forgot to do infer schema true. Okay, so make sure you do infer schema true. So this is just to explore data, right? This is just shows the news accounts. It's nothing fancy so far. Just accounts, the visualizations, right? Just simple. Well, not simple, but those visualizations are similar to examples you already have in Titanic. But see this, we're looking at the histogram for age. And in this case, in this example, most of the columns are numeric, right? So let's say I want to look at all of histograms for all of them. I can go ahead and write the code for 16 columns, for one column at a time, 16 times, right? I can do that, but I can do something else. And I'll show you when I get to it, but take a look at this. Is how you would check if the column has missing values. There are no missing values, but I just threw it in there to show you that it's possible to check, because in prior courses we talked about missing values. We don't want to forget about this concept here, right? So it's possible to check if there are missing values. This is how you would do it. They're known, but just know it's possible, right? This is just to show you the statistics. Remember that you want to see the, well, count. This is just, in this case, it's number of rows in the data. You want to see the mean, the standard deviation, minimum, maximum, etc. Remember what they call the 6-number, one number summary, something like that. It's available here, just know that, you can see that. And another thing is that if you take a look at it again for the age, you do not want the mean age to be higher than the maximum, the highest age, right? Well, that happens if you see the maximum age lower than the mean age, it means that you read the data wrong. It means that you forgot to put the infer schema. You want to make sure that you are analyzing the data, not the ASCII value of the data, okay? No, students did it. So I'm telling you, if that's the case, then here the statistics will be wrong, okay? Now earlier you look at the histogram for one column for the age, but what if I want to do all of them? And I'm a little bit lazy to write the code 16 times. Take this function, right? Well, I'm not saying that you have to do something like that, but just in general, this is a function. So what this here will do is this. It will takes a data frame. It takes a list of column names, right? The names of the columns in the data frame. It takes a number of rows and number of rows columns for display purposes. Like here, I want to show, I want to do organize my histograms into 6 rows and 3 columns in each row, right? This is just for this one. So I define this function here, right? And what it's basically doing is that it's looping through, it's going through all of the columns, and it plots the histogram for each column, all right? Feel free to reuse it, but in reality, you probably, if you were going to use it, you would probably want to check if the column is numeric, because you cannot display the histogram for non-numeric column, right? I'm not telling you that you have to use it. No, you don't have to do it, but it's something for you to take for the future, let's say. If you're interested, if you have hours, capacity hours left, if you want to play around, you have this function. Okay? We'll just say it this way. So this is just the way to do it, not one column at a time, and chooses this distribution, right? And also what I did was I put some key points on the slides, the packages that you need to import to do this. Remember, so you use the matplotlib library, right? So that's a library that you need for that. I put it here in the slide, okay? And this is just how it looks like. Then there is a package called Seaborn. right? So you need that one. If you want to do something like if you want to do this correlations map, you have to use Seaborn package, okay? And this is just plot. It just shows you the correlation between columns. And see this here, it just lists the column names here, and it lists the column names across here. The correlation in general, it goes between 1 and -1. And if the columns have a high correlation, like one example is if the person is a smoker and number of cigarettes per day, you probably want to exclude one and keep one, right? Things like that. So probably if you were going to discuss approaches to improve the accuracy of this model, you probably want to look at which fields are not independent from each other, right? You want to look at the fields where the correlation is high. Like see here, for example, here, diastolic blood pressure. See this one? And also if somebody is have the prevalent see this? These two columns you probably want to keep one or the other. Things like that, right? Where the person has a diabetes and a high glucose, probably you want to keep one or the other, right? And then diastolic blood pressure, well, usually if you have diastolic high, you're probably gonna have a systolic high. So that's another thing, right? Well, in general, if I was going to do the assignment, there is a theoretical part. What you would have done to improve the accuracy of the model. You probably want to look at the correlations to check if the predictors are independent from each other, right? So that just means this is how you would do it if you were going to do it, right? So you're gonna have this code, and you're gonna have this code here too for the pairwise plot. You have that if you want to have it, but it does take a little bit of time to run, so that's why you don't have to run it. And here again, it's just the parsing the data. Then it's building the model and it evaluating the model on training and test set. You're gonna have this output. All right. So for the part 2, so watch out, do yourself a favor and list the columns like I did here. See, do something like this. This will save you a lot of time because you can see the position of the column, right? You can see the position number, and it will help you a lot as you start editing the parser function because all errors, most of the errors that I have seen for this assignment happen in the parser function. So please watch out this one, okay? If you are careful, you're gonna get it. No issues, right? And I would recommend that you prepare the code before you actually start doing it in a notebook. There are multiple ways to approach it. Do what works for you. Some people just take the Titanic notebook and they save it as a copy and they start from it when they work on part 2, okay? Some students do it this way. Part 3 does not require hours. This is just the research. And those questions are review questions. You remember we talked about the overfitting in the earlier course, right? So what happens if the module accuracy is 95% for training data and only 60% for test data, right? That's an overfitting, and you need to discuss that part. Okay, I just gave an example. So let's look at the slides, make sure that I went through this. You're gonna have a copy of this slide deck and you're gonna have that example, okay? Oh, and always you want to save the notebook like you did in the last assignment, save it as HTML. Part of the issue is that to save the notebook as HTML, you need to open the notebook in the edit mode. In order to open the notebook in the edit mode, you must have capacity hours left, okay? So please, as soon as you're done with Titanic notebook, save it as HTML just to have it. Well, this is just speaking from the point of view as a former student, okay? Suppose that I am a student, I didn't pay attention to instructions, I ran out of hours, okay? I cannot submit my assignment on time. I cannot submit everything on time. But I know that each part of the assignment costs a certain number of points, and I want to get as many points as I can. I want to grade. I don't want to get zero on assignment, right? So I want to be safe. What I would do is this. I would save the part, the Titanic part as HTML as soon as I have it done and set it aside. So that way, if I run out of hours, if I do something stupid, I can at least finish my part one and get points for part one, right? So that's not zero. I get some points. Well, I'm speaking right now as a former student, right? So that, okay, I would get my points for part one. Then I can do part three because it does not require running the notebook, right? Then it means that I'm not gonna get zero on this assignment. I got my points for the first part, right? And I got my points on the part three. That's not zero. So that means that I'm not gonna fail the class, right? It's still possible if you get like 60 or 70% on one assignment and to still pass the class. Yes, it is still possible if you do well in everything else. So I'm gonna be safe, right? So as soon as I'm done with part one, I'm gonna just save that output and have it there. So that way, if I run out of hours, I can at least get that write up. I can still at least get those points for that part. You see what I'm saying? I'm just thinking about it now from as a former student because I was there too. Well, there were no such a thing as capacity hours in my program that I took, but there was something else, right? So I'm just telling you how the tip, how to get as many points as possible if getting 100% is not possible. You know, things happen, right? So, but in general, when you're done with the first part, save it. Just have it there. So that way you can do write up for that part. You can get points for that part. It's not zero. You get some point on assignment, right? But the best it's best scenario when you get both parts. When you can finish, use the remaining hours and finish the part two. Okay? Because the main purpose of making you write the code was to isolate the A students. Because basically, to get an A, right, no guarantee, but to aim for an A, you need to get that code working for part two. Okay? Because you cannot just be asked to just run a code. You need to write some code too, right? So that's a point here. But at least suppose that you are unable to get the method to work for part two. You can still get some partial points on part two just by defining the problem, right? Explaining what data is, you have some data exploration, right? So that also, well, I'm just assuming the very bad scenario where you couldn't get the parser function to work, but you got your data exploration part to work. So if you do write up for that part, that's partial points too, right? Well, just speaking from the point of view as a student, but in general, yes, you need to get everything to work and aim for as much credit as possible. But sometimes, if it's not possible, you know what you can do to at least get some points, right? All right. I was just breaking it down, let's say, if you will. And this is just another useful example where they build a model to predict if the heating, ventilation, and air conditioning system is operational as expected. They they build a logistic regression, right? So that's just another example here. All right. So let me know if you have questions. about this assignment or any concerns? Any concerns? Please say it. Anything you want to ask me? So, do you feel comfortable with this assignment? Let me see. I will pause the recording, of course. Okay, should we use all hours? Well, no. I would say try to use. This is a good question. You're if you're following instructions, the hours that you have should be enough. Okay, the hours that you have should be enough, but you do make sure that you do meet the requirements first. Okay. Uh, for the other assignments, well, this is what's going to happen after this assignment. Assignment 3, you will next assignment, right? The sentiment analysis tutorial, it will have 2 pieces. The first piece will you will use the DB2 database. It does not consume hours. This next piece, it does, but remember that when new month starts, the hours will be credited back to 10. So when does this assignment is due? Is due next week on the 24th, right? Okay, so here is the plan. If you run out of hours, if you run out of hours by 24th, which is when the assignment is due, hopefully not. I hope you still have hours left. But if you run out of hours, you will still be able to start next assignment and do just the database part. Okay? So next assignment will be 2 parts, right? First part is a database, DB2, that does not consume hours. Second part is R, that consumes hours. If this is not what I want to happen, I want you to still have hours after you finish this assignment. But if you run out of hours, okay, suppose that today is September 24th, you submit assignment, you have no hours left. Well, you're gonna still start the next assignment and you will do the DB2 part of it. Then, late in the evening on September 30th, right, or early morning on October 1st, the hours will be credited to 10 for October. You will be able to do the R part. Does it make sense? Because see, you have what, 2 weeks for the next assignment, right? So you're gonna start with the DB2 part. You're gonna do the walkthrough. You're gonna do the ungraded exercises, yes. And then you're gonna pick up with the R for the next month, yes. So let's see. Okay, but yeah, do not waste the hours. Conserve them, okay. But yeah, I'm glad to answer. Yeah. So that for you will need hours for the R part of the sentiment analysis assignment and the assignment 3. Assignment 4, you don't need the capacity hours. Okay? But again, if you do run out before if you do run out, just watch out, and keep me posted. Oh, no, you don't need to do anything for naive Bayes. No, 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 no. Nothing, no. Well, for naive Bayes, I would just say download the example and keep it. Just keep it. You don't have to run anything. You just keep it as an example. And let's say for the theoretical question, you ask what other methods could you use, right? Could you use naive Bayes? Just answer. Probably you could not you? Perhaps it's one of the methods that you could use. It's a theoretical, but don't do anything. Don't spend hours on it. This is just ungraded. This is just for you to have. You can take the code and keep it. I hope it makes sense. That's just the code for you to keep. We're not asked to run it. You're not asked to run it to save the hours. Okay. And you're gonna get this slides. You're gonna get the examples that I showed you, and you're gonna get the data. Because eventually, right, the class will be over, but you're still gonna have access to you still have access to IBM Cloud account, right? So in the upcoming months, you can upload and play around with this example at your leisure. So you're gonna have it, right? Because since in October, you're gonna need the hours for assignment 3, right? But then you got the November, right? And you have access. You have this account for 1 year, so. And then not just for 1 year. What's gonna happen is that you're still gonna have your student email, right? When the days on your IBM Cloud account expire, right? When you have only 1 month left on your IBM Cloud account, go back to instructions, get another code, and apply another code. And that's it. You're gonna have access for another year. Just simple as that. Well, you have your student email, right? The student email gives you access to get a new code. So every year you can get a code and apply, keep extending. Do not let your account expire. You get. Some students choose to use IBM Cloud for the capstone course. It's possible because you have it. You have an account, right? It's still good for at least another half a year, right? It's good for a year now. Used to be until the end of the calendar year. So now it's good for 1 year. They keep on changing it. Right? Any other question? Any questions? But that piece about other methods is theoretical. You don't have to do it. Sure. So please ask questions, guys. Anything. Any concerns? How things are going? Because if there are no questions, so I don't know if there are issues. So looks like this semester so far has been doing well. Nobody ran out of hours as of this point, right? Nobody entered credit card as of this point. Last semester, a couple people did not follow instructions. So you're doing much better than summer people. All right? Anything else before I call it a night? No? Well, then I guess we call it a night. And, well, let's see. Chat. Okay. And we're gonna have another session. Next session will be on I'll be doing a lot of SQL next session. Okay, I'll be going over a lot of SQL for the next assignment. It will be in 2 weeks. Okay. So see you in 2 weeks, and you know where to find me, right? You know how to submit the tickets if you need anything. All right. Have a great night, everyone. So, all right. Good luck. Oops, stop the recording.